As a continuation for our previous lesson, which is graphing of exponential function, now we will be talking about graphing transformation of exponential function. For our first lesson, we will be talking about rules of transformation. So when we say transformation, it means regardless of the function, will behave the same. This graphic organizer describes transformation on the function. It means whatever your function is, your output or your graph will stay the same. Transformations of function f of x. First, we have if the graph is horizontally right, moves the function age units right. When it's horizontally left, it moves the function age units left. Next is when the graph is vertically up, it moves the function k units up. When it's vertically down, it moves the function k units down. And when it's a reflection, the x-axis reflects the function over the x-axis. And if it is y-axis, reflects the function over the y-axis. Next is horizontal shifts and the y-intercept. If the x variable of a parent function f of x is replaced with x plus 2, every point on the function will move 2 units left. Conversely, if the function x variable of a parent function f of x is replaced with x minus 2, every point on the function will move 2 units right. So let's now try to graph the function f of x is equal to 3 raised to x using GeoGebra. But, first of all, what do you think will the graph looks like?
Using GeoGebra, let's graph to demonstrate this for the function f of x is equal to 3 raised to x. Since f of x is also known as y, so we're going to use the variable y. Y is equal to 3 raised to x. So that's the graph for f of x is equal to 3 raised to x. So let's replace it with x plus 2. So let's put here another one. Y is equal to 3 raised to x plus 2. So the blue one, as you can see, is the graph for y is equal to 3 raised to x plus 2. As you notice, the points move 2 units to the left. So let's replace it again with x minus 2. So y is equal to 3 raised to x minus 2. So let's look the graph. So the red one is the graph for y is equal to 3 raised to x minus 2. So as you notice, the point moved 2 units to the right. If you notice that the asymptotes for the three functions are all the same, all of the asymptotes are y is equal to 0 because horizontal shifts do not move horizontal lines. The asymptotes for exponential functions are always horizontal lines. And also, the y-intercepts are different for the curves. Finding the location of y-intercept for an exponential function requires a little work.
Now that you have already seen how to graph using the GeoGebra, we're now going to locate the y-intercept of an exponential function. Do you know how to determine the y-intercept of an exponential function? So to determine the y-intercept of an exponential function, simply substitute 0 for the x value in the function. So the reason this works is because all points on the y-axis have an x value equal to 0. Here is the mathematics for all three of the functions that have been graphed. First one is the f of x plus 2 is equal to 3 raised to x plus 2. So you're going to substitute x plus 2 into 0. So is equal to 3 raised to 0 plus 2 is equal to 3 raised to 2. And 3 raised to 2 is equal to 9. Your y-intercept now is 0 and 9. So the next one, you'll be having f of x is equal to 3x. So you're going to substitute x into 0. So 3 raised to x will be equal to 1. So your y-intercept now is 0 and 1. Next one is to f. F is x minus 2. So the exponent x will be substituted into 0. So you'll be having 3 raised to negative 2 is equal to 1 over 9. Your y-intercept now is 0 and 1 over 9. Next, we'll be having the vertical shift asymptote. The parent curve of an exponential function has the asymptote y is equal to 0. So what do you think will be the structure of our graph having a function of f of x is equal to 3 raised to x? So using GeoGebra, we've came up with this structure. So as you can see, it goes horizontally right.
What if we add or subtract a number to or from our parent function, which is f of x is equal to 3 raised to x? What do you think will be the structure of the graph? Let's now add 1 from the parent function. F of x or y is equal to 3 raised to x plus 1. Notice that if we add the number 1 to the function, that the function moves vertically up 1 unit. If we subtract 1 to the function, so let's subtract 1 to the function, y is equal to 3 raised to x minus 1 minus 1. The function moves vertically down 1 unit. In both cases, the asymptote follows the curve.
Next one is if you have a function of f of x plus 1 is equal to 3 raised to x plus 1, the transformation will be the curve moves up 1 unit, and the asymptote is y is equal to 1. While if you have a function of f of x is equal to 3 raised to x, your transformation will be parent function is no move, while your asymptote with that is y is equal to 0. The next one, if you have a function of f of x minus 1 is equal to 3 raised to x minus 1, the curve moves down 1 unit, and the asymptote is negative 1. Next is the reflection over x-axis. If a function and its opposite are compared, we would see that they would be mirror versions of each other. The mirror would be the x-axis in this situation. Let us examine our parent function from a previous section and its opposite function. So having a function of x is equal to 3 raised to x, it will be our parent function. And its opposite is negative f of x is equal to negative 3 raised to x. So the opposite of positive 3 raised to x is negative. That's why we have a negative sign in the opposite function.
Here are the graph. For the parent function, which is f of x is equal to 3 raised to x, f of x is equal to 3 raised to x. So that is the graph for the parent function. Now, the graph for the opposite function, which is f of x, f of x is equal to negative 3 raised to x. That is the graph for the opposite function. This demonstrates how the transform function is obtained by flipping the original function over the x-axis.
The first example is g of x is equal to 4 raised to x plus 2 plus 1. So the parent function is h of x is equal to 4x. So substituting the x will be 0. So g of 0 is equal to 4 raised to 0 plus 2 plus 1. So 0 plus 2, you'll be having 4 raised to 2 plus 1. And 4 raised to 2 is 16 plus 1. 16 plus 1 is equal to 17. Your y-intercept now is 0 and 17.
Example number 1. G of x is equal to 4x plus 2 plus 1. Let's compare this with its parent function, which is h of x is equal to 4 raised to x. To graph g of x, we would have to move h of x 2 units left and 1 unit up. So, g of x is equal to 4 raised to x plus 2 plus 1. The number next to the x value is the horizontal shift, and we have to take the opposite to determine the direction of the shift. The plus 2 really means 2 units left. The plus 1 is not next to the x value, which means it is the vertical shift number. So this is the graph of the g of x is equal to 4 raised to x plus 2 plus 1. Now, let's compare it with its parent function. The parent function is h of x is equal to 4 raised to x. The asymptote of h of x, which is y is equal to 0, will shift up 1 unit along with g of x. This will make the asymptote of g of x equal to y is equal to 1.
K of x is equal to negative 2 raised to x minus 1 minus 3. The asymptote is y minus 3. And our parent function is negative 2x. So substituting again the x, we will be having k of x, k of 0 is equal to negative 2 raised to 0 minus 1 minus 3. So 0 minus 1 is negative 1. We'll be having negative 2 raised to negative 1 minus 3. Simplifying, we'll be having negative 1/2 minus 3. And the final answer is negative 3.5. So our y-intercept now is 0 and negative 3.5. So that is all, and I hope you learned something from our tutorial video.